Okay, so here we have incoming light hitting cathode tube, and the electrons are accelerated from plate 1 to plate 2, off of plate 1 to plate 2. The wavelength incoming is 240 nanometers, and they tell you here that the stopping potential is 1.4 electron volts. So what is the energy of the photons and light for the light beam incoming? So we know the energy is equal to Planck's constant times the frequency. We know the speed of light is equal to the wavelength and the frequency, so the frequency is equal to the speed divided by the wavelength. I can make this substitution and find out when I calculate everything. I have 4.14 times 10 to the negative 15th electron volts times seconds times 3 times 10 to the 8th meters per second divided by 240 nanometers, which is times 10 to the negative 9th. Ultimately, we would get 5.17 electron volts. So the energy of that incoming light is 5.17 electron volts. That's enough to accelerate them off there, and the electrons will have a certain amount of energy after. So what is the maximum kinetic energy of the emitted electrons? So to figure that out, the maximum kinetic energy of the emitted electrons, the kinetic energy electrons will equal the energy of the incoming light, all right, which is what we just calculated, the 5.17 minus the work function. So this is going to be 5.17 electron volts minus 1.4 electron volts will give us an answer of 3.77 electron volts. So that is the maximum kinetic energy those electrons can have after accelerated off the plate. The work function here was given in the problem, 1.4 electron volts. And then what is the longest wavelength that would cause the electrons to be emitted? So the reason they're asking for the longest wavelength, it will be the lowest energy because it'll have the lowest frequency photon that'll cause us to be emitted. So basically, we want to know the wavelength of those photons that will barely cause the electrons to jump off. So I'm going to rewrite the energy of the photon as hc divided by lambda, because ultimately I will need lambda. And then we know, because we're looking for the ones that just make it off plate 1, that the kinetic energy here is going to approach 0. So we're going to call this 0. I know that 0 looks like the work function, but this is 0 is equal to hc over lambda minus the work function. Or the work function is equal to hc over lambda. Lambda is equal to hc over the work function. And if we calculate this out, we get 4.14 times 10 to the negative 15th electron